Question number 14. Water is pumped through a nozzle at the end of a hose. This is your hose pipe, right? The nozzle has a circular cross section of diameter 50 millimeter. This is your 50 millimeter, which means your radius would be 25 millimeter. A mass of 100 kg of water takes a time of 2 seconds. See, when mass is given and time is given, somewhere it should either be the force or it should be flow rate. And especially when it is something like liquid, it should definitely be flow rate. Now, what is okay? The density of water is given. What is the speed of water in the nozzle? Flow rate has two formulae. Okay, this you should know. Flow rate is nothing but volume by time. Okay, you can also write this as equal to velocity multiplied by area. Okay, you can use either of them, or maybe you will be using both of them. Now, first let us use this one, volume per time. What is volume? Volume, is it given? Volume is not given, but mass is given, density is given. You can find volume. So this should be mass by density divided by time. Okay, and this should be, what is mass over here? 100 kg divided by 10 cube divided by time. What is time taken? 2 seconds. So which should now be equal to how much? 10 power minus 1 divided by 2, which should be equal to 0.5 into 10 to the power of minus 1, or this is 5 into 10 to the power of minus 2 meter cube per second. This is the flow rate, okay, which I calculate using this. Now using this, if I calculate, I get V into A. Now what is that I need to find? I need the value of V. Is the value of A given? A is given here, A is not given, diameter is known, radius can be found out. So V into A is nothing but V into pi r square. What is this? V into 3.14 multiplied by, what is R? R is 625, R is 25, this should be 625 into 10 to the power of minus 6 millimeter, right? Minus 6. Okay, so I have squared it, I got the final answer here. Let me simplify this also using my calculator so that I can equate both of them. So I will write 3.14 into 625 is equal to 1962.5. 1962.5 into 10 to the power of minus 6. What is this? Meter cube per second. Now what did I say? I said that the flow rate can be written by this, can also be written by this. Now you can equate these two. When I equate this, what do you mean by that? I can now write, so there's a V here. There's a multiply this by V. Multiply this by V. See, this V I left it. This quantity inside the bracket is this value. So I can now write V is V into 1962.5 into 10 power minus 6. V into 10, this one should now be equal to 5 into 10 to the power of minus 2. I am equating these two. Okay. So therefore, value of V should now be 5 into 10 to the power of minus 2 divided by 1962.5 into 10 to the power of minus 6. Okay. No approximation. Just write down what you get and later on you can approximate. Now let us calculate the value here. So now this should be 5 divided by 1962.5. I get this as 0.00254. 0.00254 into 10 to the power of, here you have minus 2 and here you have minus 6. Minus 6 goes upwards, becomes plus 6. Plus 6. So this becomes 0.0025 into 10 to the power of plus 4. See, 1, 2, 3, 4. This should be 25. Okay. What is the unit? Meter per second. 25 meter per second. C is the right answer.